we're just going to talk more generic. Before we actually define our trig functions, we need to create another variable or find another variable. So if I were to give you an angle in standard position, remember standard position, think that xy axis, the vertex is at the origin, the initial side is the positive x-axis, and we have some point on the terminal side. Okay, it could be in any quadrant. I'm just drawing an angle and point xy is on this side. If I want to know how far it is from that point to the origin, I am looking for this distance right here. Okay. If I called that r, we could solve for that. If we think of this as a triangle, what is the distance from the origin to here? It's just the amount we travel to the right is our x value. The amount we travel up is our y value. And so then we could think about in a triangle, Pythagorean theorem, x squared plus y squared equals r squared. So if you're getting r by itself, it is the square root of x squared plus y squared. So that is something that we are going to be using. Good news is, if you forget that, it's not that hard to figure it out. It's just using the Pythagorean theorem here to solve for that. So now that we have this, and we kind of understand why r is square root of x squared plus y squared, we are going to write down our definitions of our trig functions. So xy in this definition is just any point other than the origin on the terminal side. So it's an ordered pair, not the origin. So the trig functions are just ratios. It's a value you get when you divide two sides. So the definition of sine is y divided by r. Okay, this is read as sine of theta. It's not sin. Pronounced sine. And we always have a theta, an angle that tells us where we are looking. So sine of theta is just a ratio found by doing y divided by r. This cos, that is called cosine. So cosine of an angle is defined to be x divided by r. TAN, that's called tangent. So tangent of an angle is y divided by x. These other threes are reciprocals. CSC is cosecant of theta, and that's just the reciprocal of sine, r over y. SEC, that is secant, and that's the reciprocal of cosine. So that is r divided by x. And this is cotangent. Which is x divided by y. Is that okay? So we don't only apply these to triangles in trig. Sometimes it's triangles, sometimes we're looking at circles and other things. But we can use the triangle definition to help us remember. So SOHCAHTOA, you've probably heard that before. It applies in a triangle. So if we think about, our angle and standard position, this is our angle. And these were the sides. The horizontal side is your x, the vertical side is your y. And we call r the hypotenuse. But you can also use the terms opposite, adjacent, and hypotenuse to think about it. So r is hypotenuse because it's across from a right angle. We call y the opposite side here because it is opposite my ankle. It doesn't touch that ankle, it's across from it. X is touching my ankle, but it's not the right angle. That is what's called the adjacent side. Adjacent is touching. So, we look at these letters. So, tells us sine is opposite divided by hypotenuse. So opposite over hypotenuse. Which, if we look at our picture, the opposite side is y, the hypotenuse is r. So it's the same ratio I gave you before, y over r. Just use that so to help you remember it. And then sine is the reciprocal of cosecant, so we just flip it for cosecant. So then cut says cosine of theta is the adjacent side divided by the hypotenuse. Okay, and if we're looking, our adjacent side is x, the hypotenuse is r, x over r. That's the ratio I gave you on the previous slide. If we have that ratio, we can flip it for secant, because cosine and secant are reciprocals. So TOA says tangent is opposite over adjacent. If we look at our picture, our opposite side is y, our adjacent side is x, and y over x is the same ratio we wrote down before. then we flip that for cotangent. So right now we're really just learning these definitions. You can't only think of it as SOHCAHTOA, which is why I gave you the other definition as well involving x, y, and r, because there are cases where it is impossible to draw a triangle. If I said you have a triangle or an angle where your terminal side is up here. Okay, if I take a point on this terminal side, is it possible to draw a triangle on that? No. So then we couldn't use that SOHCAHTOA definition. So because of that, we can't only rely on this, but most of the time we can, and we can use that to help us remember the x, y's, and r's. So now we're just going to use this and practice a couple problems. When we are giving our trig ratios, we want them to be as precise as possible. So typically that means I'm going to avoid decimals. I'm going to keep things in fraction form because I don't want to round. Lowest terms, obviously, if it's 6/8, we would reduce that. We also will sometimes have radicals, and we're going to keep the radicals. Don't try to plug it into your calculator and get a decimal. We want exact answers for everything in trig. So if I tell you the terminal side of an angle theta in standard position passes through the point 12, 5. Find the values of the 6 trig functions of angle theta. You don't have to draw a picture, but you certainly can if it helps. I have an angle in standard position. What quadrant would 12, 5 be in? I should go over 12 and up 5. And you don't even have to have exact points. All we really care about is just like a rough sketch. But if I think about this, that's my angle right here. And I want my 6 trig functions. We do have to put the theta with them. Sine by itself just tells you you're dividing two sides. You have to know from where, so it's from angle theta. So 2 ways to think about it. When I think about the definition of sine, that's y over r. Okay, from my picture, or from my point, I know my x is 12, my y is 5. How am I going to get r? What did we do on the very first slide? What did we say r was equal to? And if you don't remember that, it's just like a Pythagorean theorem. You know, we could think about in this triangle, go over 12, up 5, so x squared plus y squared equals r squared. So if you need to go back and work it out, it adds one more step to the problem. It's not a big deal. So we get 44 plus 25 equals r squared. So r squared is 169. R is always positive. So it's 13. So if I ask you to find y divided by r, we could look, okay, in this, I said my x is 12, my y is 5, my r is 13, so y divided by r is 5 over 13. Or if you didn't remember that, if you drew the picture, you could think SOHCAHTOA. Sine is opposite over hypotenuse from this angle. My opposite side is 5, my hypotenuse is 13, so 5 over 13. Cosecant is the reciprocal of sine. So sine is y over r, so that means cosecant, if you flip it, is r over y. gives me 13 over 5. Is that okay? So cosine, if you remember the definition, cosine is x over r, or you can think adjacent over hypotenuse. My x is 12, my r is 13, or I can think from my angle, my adjacent side is 12, hypotenuse is 13. Secant of theta is a reciprocal, so r over x, or just flip your fraction, 13 over 12. Tangent, the definition is y over x, or TOA, opposite over adjacent. So that's 5 over 12. Cotangent flips those, so x over y, or 12 over 5. So picture is optional, but if you did it, 8, -6 would be here. And so if you're looking at your triangle, this is your angle. We went right 8, down 6. And we have to find r. So you can remember the shortcut. R is the square root of x squared plus y squared. If you don't, go back to Pythagorean theorem. Either way. So when I plug that in, so we get r to be the square root of 100. So r is 10. So do we agree with that much? So then our ratios. When you write this, we need to get in good habits now. You can't just say sine equals. Sine just means divide two sides, but you have to tell it from where. So it's sine of theta. So if you know the definition, y over r, or if you think SOHCAHTOA, this is my opposite and hypotenuse. So either way you want to think about it. My y is -6, r is 10, that reduces to -3/5. And which one is the reciprocal of sine? So that's our r over y, or you could just flip this finally, so -5/3. So cosine, x over r, or if you think SOHCAHTOA, adjacent over hypotenuse. So my x is 8, hypotenuse is 10, so that's 4/5. So the reciprocal secant is 5/4. Tangent, TOA, y over x, or opposite over adjacent, so -6 over 8, -3/4. So the reciprocal cotangent is x over y, or -4/5. Did we do okay on this? I would like to do one more today. And it's going to be a little bit different. So if I tell you I want to find the values of the 6 trig functions of angle theta in standard position if the terminal side of theta is defined by the equation 3x minus 2y equals 0, and x is less than 0. Alright, this is a little bit different because I didn't give you an actual ordered pair. But I gave you a formula for an ordered pair. Now, one thing that we need to talk about when we are doing these trig functions, you know, I gave you a particular point on this terminal side. But if I picked a different point, like if I went with this one, my triangle changes. X, Y, and R would all be bigger. Would I get different answers for my trig ratios? No, because what's going to be true about those two triangles? Remember yesterday what we called those triangles? Because the angles will all be the same in them. So they are similar. That means they're proportional. So when you divide their sides, you'll get the same thing. So it turns out that no matter which point we pick on this terminal side, we would get the same ratios for our 6 trig functions. So in this problem, it doesn't matter which point I pick on this line. I just need a point. And we could all do different ones, and we'll get the same ratios at the end. Now we do have to follow the rules, and the rule I told you is x has to be less than or equal to 0. Now 0 is the origin or the vertex, so we don't want that point, but we want any other negative value is fine. So what do you want to try for x? Pick a number, we'll use it. -2. Alright, so if we said x is -2, it fits the rule because it's less than 0. So we plug that into our formula. Then y would be -3. So now I have an x, and I have a y. Now it wouldn't matter which x and y you picked. You know, I could have easily done -1 for my x, and that would have given me -1/3 for my y. So we can do different values, but we have to find r. So r is the square root of x squared plus y squared. So x is -2, y is -3. That's 4 plus 9, which is 13. That doesn't reduce. So we are just going to keep it as radical 13. Now if it were something like the square root of 8, I do want you to break it down and make it to radical 2. So if you can reduce, please do so. All right, so now we can do our 6 trig functions. The definition of sine is y divided by r. My y is -3. My r is the square root of 13. Can I leave that for my final answer? The only thing I don't like is the radical on the denominator. How do we get rid of it? So that would give me a -3 radical 13 over 13. So we just multiply by the square root of 13 to get it off top and bottom. An algebra trick there. The reciprocal of sine is cosecant, so that would be r over y. So that would be r is radical 13, and y was -3. So negative radical 13 over 3. Cosine. X divided by r. So my x is -2. My r is the square root of 13. Multiply top and bottom by radical 13. And we get -2 radical 13 over 13. reciprocal of cosine is secant. So secant is r over x. So negative radical 13 over 2. Tangent y divided by x. So negative 3 over negative 2 would give me a positive 3/2. Cotangent theta x over y is positive 2. Any questions on those? We will do more like that tomorrow, but I'm going to stop there for today. So we're not done with the section yet. Technically, you could do all of this, but it won't be due until after we finish the section. So if you get stuck or don't get to it, that's fine. You'll just have to catch up tomorrow. So this will all be due, let's see, today's Tuesday, so Thursday.